All right, in this video, we're going to look at balancing by the half reaction method. And if you look in your slides, you'll find a problem that asks you to balance the following reaction in acidic solution, where you have MnO4 minus plus Cl minus going to Mn2 plus HClO, everything in an aqueous state. And when we're balancing by the half reaction method, the first step is to split them up, right? What's being oxidized and what's being reduced. But it's easy. You don't even have to think about it that far. Just match up, right? What is not hydrogen or oxygen? So in this case, I've got a reaction with chlorine and I've got a reaction with manganese. So that's step one, split them up. Next, I balance everything that's not hydrogen or oxygen. And in this case, that's already done. One chlorine on each side, one manganese on each side. Next, I balance oxygen by the addition of H2O. Okay. So no oxygen over here, one oxygen in HClO. So I need an H2O over here. My second reaction, 4 oxygens, no oxygens. So I need 4 H2O over there to balance out my oxygens. Then I look at my hydrogens. Okay. My top reaction, I have 1 hydrogen and 2 hydrogens. So I need an extra one over here. No hydrogens, 8 hydrogens. So I need 8 hydrogens on the left-hand side. So now I've balanced all the atoms. The last step before I start comparing my reactions is to balance the charge. And in my top reaction, water is neutral. Chlorine has a -1 charge, so that's -1 on the reactant side. Neutral, +1 on the product side. Yep. So I need to add 2 electrons to my product side up top to bring the total charge down to -1 and be equal on both sides. My bottom reaction, 8H+, so that's +8. MnO4 minus, it's -1, so a total of +7 on my reactant side. Versus down here, +2 and neutral means I have +2 on my product side. So +2 and +7, I have to add 5 electrons to bring that +7 down to a +2 and be equal on both sides. And this is the first place you can check yourself. Okay? If after you have your 2 half reactions, the electrons are not on opposite sides, something went wrong and you should start over. Because the next step is to multiply your 2 half reactions by an integer to make those electrons be equal to one another. So what's the lowest common multiple between 2 and 5? 10. So that means I have to take my whole top reaction, multiply everything by 5. My whole bottom reaction, multiply everything by 2. So I'll rewrite those. My top half reaction becomes 5 H2O plus 5 Cl minus goes to 5 HClO plus 5 H plus 10 electrons. My bottom reaction, 10 electrons plus 16 H plus 2 MnO4 minus goes to 2 Mn2 plus 8 H2O. And now the half reaction method tells me to bring everything back together, all my reactants and all my products. So I'll rewrite that as one big reaction, 5 H2O plus 5 Cl minus plus 10 electrons plus 16 H plus 2 MnO4 minus goes to 5 HClO plus 5 H plus 10 electrons plus 2 Mn2 plus 8 H2O. Okay, ran out of room, so I had to carry it down there. Then I compare the reactants in the product side and cross out anything that appears on both sides. So 10 electrons, that's the whole goal. That's going to go away. What else do I have? 5 H2Os over here, 8 H2Os over there. So these 5 will go away completely, which will bring my 8 down to a 3. Okay. Anything else? 8 or 16 H plus, 5 H plus. Okay, so those 5 will go and take that 11, or that 16 down to an 11. That takes care of everything on the reactants and the product side. So the final step is to rewrite the reaction, including my states. 5Cl minus aqueous plus 11H plus aqueous plus 2MnO4 minus aqueous goes to 5HClO aqueous plus 2Mn2 plus aqueous plus 3H2O, which is a liquid. Okay. Then I can check my answer. 5 chlorines, 5 chlorines, 11 hydrogens, 5 hydrogens here and 6 more down there, so 11 hydrogens. 2 manganese, 8 oxygen, 5 oxygen here, 3 oxygen there, 8 oxygens. So the number of atoms is equal on both sides. That's good. What about the charge? 2 times -1, 5 times -1, so that's -7. 11 times +1, -7, and 11 plus, right? That's a +4 overall. Neutral, neutral, +2, and there are 2 of them, +4 overall. My atoms are equal on both sides. My charge is equal on both sides. I'm confident that I have the final answer here, balancing by the half reaction method.